Hello everybody, hope all of you are well, and today I discuss the answers of your last revision test. Your first question was MCQ type. Question 1 was, which of the following is not an organic compound? Options are given: A. Urea. Option B is given ammonium cyanide. Ammonium cyanide. Option C is given hexane. Option D is given speed. Here you know that there is the first organic compound prepared in the laboratory, that is urea, and it was prepared from an inorganic compound, that is ammonium cyanide. So ammonium cyanide is not an organic compound. Hexane is organic compound, okay, and speed is also containing ethyl alcohol. So definitely it is an organic compound. So your answer of the first question will be option B, ammonium cyanide. Formula is NH4CN. Okay. Next question, the IPSC name of CH3 CH2 CO whole twice O is, options are given: propionic anhydride, propionic anhydride. Option B, dipropanoic anhydride, dipropanoic. Option C, ethoxypropanoic acid, ethoxypropanoic acid. And option D is given, that propanoic anhydride. So definitely the compound is an anhydride. Okay. So here total number of carbon will be each side, there will be 3. So it is this anhydride is formed by the dehydration of propanoic acid. So definitely its name will be propanoic anhydride. That is the correct name. So option D will be the correct. Next MCQ, question number 3. How many methyl groups are present in 2,5-dimethyl 4-ethyl nonene? Options are given: 2, option B is 3, option C is 4, option D is 5. So here from the name we can easily understand that definitely there will be 2 methyl group. One is at 2 position and another is 5. So if you draw the structure, you will find 2 methyl group and 1 ethyl group is there. So definitely your answer will be the option A, that is the 2. Next question, that cis and trans to butene can be distinguished based on their dash. Option is given optical properties. Option B given dipole moment. Option C is given reduced products. Option D is given chlorinated product. So you know that this is the trans to butene and this one is cis to butene. So because of the presence of the I, okay, it is centrosymmetric molecule, okay, as well as here this bond moment will be cancelled by this bond moment, okay. Here if we write CH3, this is CH3, okay. So here dipole moment will be 0, almost 0. So its dipole moment is very low, okay. And here actually these hydrogen will cancel each other, and this methyl will cancel the dipole moment. But here two methyl in the same site. This is the two methyl group. Okay. So because of this two methyl group, it has higher dipole moment. These are the hydrogens. Okay. So your answer will be the dipole moment. Generally, you know that trans compound, okay, has less dipole moment and cis compound has higher dipole moment. Okay. So here question was cis and trans to butene can be distinguished based on their dash, based on their dipole moment. Next question was a racemic compound is dash. Option A was given dextrorotatory. Dextrorotatory. Option B was liborotatory. Option C is given optically inactive mixture. Option D is given optically active mixture. Okay, so we know that racemic compound, that means enantiomer 50-50%. One is plus dextrorotatory, another is minus. So these two compound will cancel each other. So racemic compound means racemic mixture we are telling. Okay, so it is a mixture of 50% plus and 50% minus isomer. Understand that we are telling about the optical rotation. So definitely racemic compound will be optically inactive mixtures. The option C will be the correct answer. Okay. So these are the MCQ. Next, fill in the blanks type of question. Question number 2. 1. Tertiary carbocation is dash stable than benzyl cation. Here your answer will be more. tertiary carbocation will be more stable. Okay, you can ask that, sir, in case of benzyl cation there is resonance, but in case of tertiary carbocation there is free interactive effect of the methyl group that is trying to neutralize this positive charge, as well as 9 alpha hydrogen is present, so 9 hyperconjugated structure will be there. So that overcomes the resonance effect of this benzyl. That is why tertiary carbocation is more stable compared to the benzylic cation or allylic cation. That you have to do. Next fill in the blanks was 2. Electron deficient bases. Electron deficient species are called dash. Definitely it will be electrophiles. Electrophiles. We can think about that NO2 plus. Okay, this is an electron deficient basis. Okay, so that means electron deficiency is there, so it will want to accept the electron. Okay, so definitely they are called electrophiles. If they are electron species, okay, or nucleus loving species, then they are called nucleophiles. Next question 3. Hyperconjugation is called dash resonance. Answer will be no bond resonance. Actually, when you draw the hyperconjugated structures, then between the hydrogen atom and the carbon there will be no bond. Okay, that is why it is one type of resonance also. So that is why it is called no bond resonance, and this is also called Baker-Nathan effect. Next question, question number 4. Hexane has dash chain isomer. So here you have to calculate. Okay, so hexane structure will be like this: 1, 2, 3, 4, 5, 6. This will be one structure. Now if you take one methyl, here will be one methyl, and in the middle there will be one methyl. You can think about the 2 methyl group. These 2 methyl group be here. So in this way we got how many structure? In this way we got 4 structure, and there may be 2 methyl group at this one and this one. So from here total number of isomer will be 5. So there is no rule to calculate the isomer. You have to draw and check that all are different from each other. Okay. So in case of hexane you will get 5 chain isomers. Next question number 5. Fill in the blanks. Dash tartaric acid is optically inactive. Okay, so definitely it will be the mesotartaric acid, because if you draw the structure of mesotartaric acid like this, it contains a sigma plane of symmetry that divides the molecule into 2 equal halves. Okay, one half is the mirror image of the other. So because of this sigma symmetry, it is achiral. Okay, that is why it is not optically active. Okay, so that is why mesotartaric acid is optically inactive. Next short answer type of question is there. Your first question, question number 301 was write IPSC name. IUPAC name of glycerol. Okay, first you have to know glycerol is the common name. You have to draw the structure. CH2H is trihydric alcohol. So here you have to write 1, 2, 3, and IPSC name will be propane 1, 2, 3 triol. Okay. Next question was, what is the functional group present in TNT? TNT structure you have to draw. This is trinitrotoluene. So three nitro groups are present. Methyl is not a functional group. So this nitro functional group is present. You have to write nitro group is present as functional group. Next question, name one heterocyclic aromatic compound. You can write that PD. As it is obeying the Hooke's rules, this is aromatic, and as in cycle, all are not carbon, one heteroatom atom is present, that is why it is heterocyclic aromatic compound. Next question is given, which one is the principal functional group between ketone and aldehyde? If you see the prevalence list, definitely aldehyde is the above, so aldehyde will be the principal functional group, not the ketone, when both are present. What is meant by center of symmetry? Center of symmetry, a molecule is said to possess center of symmetry, okay, only if a straight line drawn from every atom to the center of the molecule, and when extended an equal distance in the opposite directions, it encounters an identical atom. Okay, if I draw one molecule, then you can easily understand. Suppose this compound. Okay. What will be the name of this compound? This is trans compound. Okay. 1,2-dichloroethene. Now, in this case, what is happening here? If you consider one point and if you draw a straight line, the opposite side in equal distance, you will meet the same atom. So because of the center of symmetry, this molecule will be optically inactive. Okay, and we can draw another type of compound. Here, Cl, hydrogen, and C. And here we are writing that Br is here, Br, H and H. So inside the molecule, if you consider a point like this is the center of symmetry. If we draw a line just in the opposite direction, then at the equal distance we will make the same chlorine atom. Here also, we are getting that equal distance bromine atom. Here also, in equal distance, we are getting this hydrogen atom. Then this point is called center of symmetry. Okay, and this type of symmetry is called center of symmetry. Understand? So, next question is given, which one has had dipole moment between vinyl chloride and ethyl chloride? Which one? Question number 6. Which one has higher dipole moment between vinyl chloride and ethyl chloride? Okay, so vinyl chloride will be like this, and ethyl chloride is this one. As chlorine is more electronegative, so it will be delta negative, it will be delta positive. Definitely the dipole moment will be towards the chlorine, bond moment towards the chlorine. So here mu is equal to mu sigma only because of the sigma bond. But in this case, what is happening? There is resonance. We have already told you or informed you that there will be four type of resonance. This is non-bonding and pi conjugation, non-bonding electron and pi conjugation. This type of resonance. So here chlorine will become positive. This will be negative. Okay. So because chlorine is more electronegative, so sigma moment should be towards chlorine here. But after resonance, what is happening? That the bond moment is just opposed. Okay, just pi moment is opposed. Okay, in the just in the opposite direction. Understand? So here is the mu observed value. So the dipole moment of this compound mu observed is equal to the mu sigma value minus mu pi value. Yes, pi is opposite. Okay, that is why this dipole moment will be lower. So question was which one has higher dipole moment between vinyl chloride and ethyl chloride. So your answer will be ethyl chloride. So ethyl chloride has higher dipole moment. Again, I am telling that this dipole moment of this vinyl chloride decreases because of resonance, and their mu observed is equal to mu sigma minus mu pi. And because of this resonance, there is forming one pi bond, and the bond moment is just becoming opposite, okay, in direction. That is why the observed dipole moment will be subtracted, okay, from this mu sigma value, okay, because of this bond moment, and it will be lower. So definitely the ethyl chloride has higher dipole moment. Next question was name and condensation reaction. Okay, condensation means where two molecules, okay, will react with each other, okay, the same molecule, okay, and there will be formation of carbon-carbon bond with the elimination of water molecule like this or other molecules, okay. So here we can tell the name of aldol condensation reaction. Already type of reaction is given in your book, okay. Why alkanes do not show geometrical isomers? Actually, if we draw the structure of alkane, here all bonds are single bond. So definitely there will be free rotation around single bond. Okay. So one isomer, or here better you can tell one conformation will be converted to another conformation. Okay. Very easily, and the energy barrier is very low. Okay. So it will never show geometrical isomers. Geometrical isomers have high energy barrier. Already we have discussed in our previous revision test. Okay. So here question was why alkanes do not show geometrical isomers. Here I have to write that because of free rotation around carbon-carbon single bond, the isomers are easily interconverted from one to another. Okay, and the energy barrier is very low. That is why this type of alkanes do not show geometrical isomers. Next question was define enantiomers. Enantiomers are those optical isomers which are non-superimposable mirror image of each other. Okay, so I can show you that in case of active cationic acid. Okay, so this one is active cationic acid. So if you take the mirror image, so now these two pair is called enantiomers. So these isomers, okay, are optically active. This one is optically active, this one is also optically active, okay. And one isomer is the mirror image of the other, but they are not superimposable. You can think about our two hands, okay. They are mirror images of each other, but not superimposable. That is why they are called enantiomers. And next and the last question was that each 2-chlorobutane is optically active. is 2-chlorobutane. Optically active. So first you have to draw the structure. Here one chlorine is there. Now here definitely one hydrogen is also attached. Here one methyl group. This one is the ethyl. So definitely this carbon is the chiral center. And this carbon is attached with 4 different groups. Definitely this compound will be optically active. When a molecule is devoid of any kind of symmetry, okay, or if you take the mirror image of this molecule, that will be not superimposable, then you can tell that this compound is optically active. Hope you can understand. So in this way we have discussed all the answer of your last revision test. So today up to this, thank you.